A very good morning, students. Welcome to day 6. In previous class, that is in day 4 and day 5, these classes, we discussed that is how such a long DNA condensed or packed in a small nucleus, and that heading which we learned, that is nucleosome in eukaryotes and nucleosome in prokaryotes, like that. So during that process or concept, we learned that the DNA wraps around, that is the histone protein, and the behind principle is, that is the charge on protein is positive, charge on DNA is negative. That is the only reason why here the DNA is going to tightly pack or coil around the histone proteins. Next, in eukaryotes, we saw that is a histone protein which is made up of basic amino acids, and hence the protein is basic, having positive charge. And then in eukaryotes only, we also discussed about NHC, that is non-histone chromosomal protein, which are acidic in nature and they help in higher level of coiling, that is during chromosome formation. Okay. Next, coming to packaging in prokaryotes. In prokaryotes, we have which type of protein for the packaging of DNA? That is, it is a non-histone protein. Again, non-histone protein is basic only. Okay, but it is non-histone. Prokaryotes lack histone protein. They have only non-histone protein. Here, non-histone protein attracts that DNA of prokaryote and forms a coiled, supercoiled form. That is a structure which we call nucleoid or genophore or supercoiled form. Okay. In prokaryotes, which is a single one cell, don't have any proper nucleus. In the cytoplasm only the DNA is present. Okay. So this we discussed in last class, like that. So coming to today's class, that is today whatever up to now, whatever we learned, we are going to discuss few questions regarding the previous classes, and which are very helpful for your medical entrance exams regarding this chapter. Okay, few examples are here, few questions are here. Okay, so if you understood already the previous classes very well, then you can solve these questions. So first we solve few questions and then we move to the search for genetic material. Okay. Search for genetic material, nothing but that is again DNA is a genetic material, like that, the proof one. Such experiments are conducted by many scientists. That heading we will discuss after completing this one. So first, a normal question given here, just concentrate here. A question is given here, that is, here given is one single strand of DNA. Understand question first. Here given is one single strand of DNA and calculate in double strand of DNA and calculate in double strand of DNA. That is one. So it means here one single strand is given, okay, and some questions are given, that is to calculate. What are those questions? Two questions are here. So what they told, here given is one single strand of DNA, that is single strand they give, and calculating double strand of DNA. What we have to calculate? These are here. Number of hydrogen bases, number of phosphodiester bonds. Okay. First, what we have to do, calculating double stranded of DNA, when they told, first we have to make it double strand. And now you know a rule of that is complementarity. Complementarity rule, what is that? Totally, according to Charles' law, adenine pairing with thymine, that is purine pairing with pyrimidine. Okay. Now here A pairing with T. First form this second strand of DNA. Then only we can solve these questions. Okay. Then A pairing with T, G pairing with, that is C. Again C pairing with G, T pairing with A, and A pairing with what? That is thymine. G pairing with cytosine C, and then T pairing with adenine. This G guanine pairing with again cytosine. This adenine pairing with thymine, like that. So on the basis of complementarity principle, we already drawn here the bases, the respective bases on the opposite strand. Now remember, this is the one strand which is given with the question, and they ask the few numbers, okay, in its double strand. So first we convert it into double strand, that is one strand moving from 5 prime to 3 prime. It means another strand will have polarity what? That is 5 to 3, like that. One is having 5 to 3 polarity, another is having 3 to 5 polarity, or vice versa, you can tell, like that. So number of hydrogen bonds. Here the asked question is to count or to calculate number of hydrogen bonds. How can we calculate? That is, first separate out what are, that is adenine and thymine here. How many adenine are there and thymine here? That is 1, 2, 3, 4, 5 total. What are there? 5 adenines. 5 adenine. They are pairing with what? Thymine. Okay. That is each base pair. This one, that is adenine pairing with thymine with how many hydrogen bonds? 2. Okay. Of course, adenine pairing with thymine, that is with 2 hydrogen bond. It means how many adenine and thymine base pairs are there? That is 1, 2, 3, 4, 5. It means here 2 into 5. It will give how many hydrogen bonds? 10 hydrogen bonds first. And what about guanine and cytosine? That is 1 guanine, cytosine, and then guanine, like that. This is one. This is another one. That is second one. 1, 2, 3, 4, like that. Now here G pairing with C with how many hydrogen bonds? 3 hydrogen bonds. And how many bases are here? Base pair. Guanine pairing with cytosine. How many base pairs are there? 1. Just concentrate here. 1. That is guanine, cytosine, guanine, and guanine. Here opposite will be guanine, cytosine, guanine, cytosine, cytosine, guanine, guanine, cytosine, like that. So totally 4 bases are there. That is again you have to calculate simple, like here 3 into 4. What is 3? Number of hydrogen bonds between guanine and cytosine, or cytosine and guanine. That is 3. And how many base pairs are there which are formed by guanine cytosine pairing? That is 4. How it will be? 12. Total number of hydrogen bonds, that is 10 plus 2, 12. It will be 22. Okay, I will write here. It will be 22. So this is how we can calculate the number of hydrogen bonds. Now coming to phosphodiester bond, I told you already. Simple, I will repeat here. Phosphate here pairing with, that is 5th carbon of sugar, and at the carbon number 1 who is going to pair? Adenine or whatever it may be, nitrogen base, adenine or cytosine, thymine, guanine, all these things. So this is one phosphodiester bond, this is one phosphodiester bond, another phosphodiester bond here, like that. So number of, that is total, what is here given, number of hydrogen bonds? 22. Now how many bases are there? First count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. In one strand, that is bases on one strand equal to what? 9. And again bases on opposite strand equal to, it will be again 9. And I told you number of bases minus 1. Reason? Because the final phosphate will be free, having the 5 prime moiety, that is one. Moiety is nothing but linking. It will be linking to the 3rd carbon of its succeeding ribose sugar, like that. So here number of base pairs, that is in one strand is 9, in other strand is 9. So 9 minus 1, again 9 minus 1. Totally it will be 18 minus, on 2 strands in the sense 18 minus 2, it will give, that is 16 phosphodiester bond. Very easy. That is 16 phosphodiester bond. How it is? 8 and 8. That is 16. Simple. So like this questions will be there and you can solve. Now coming to next very interesting question. Okay. The question is given, that is on the large scale like that. But out of these, on a single question we are going to solve 18 questions or 18 calculations or problems regarding the DNA molecule again. So out of these 18 questions, they may ask one or two for your one question. Not all the questions are asking at a time. So they may ask this one, they may ask this one, they may ask this, they may ask this, like that. Anything they may ask, but the question may come like these type only. So first read the question. From the one question only we are solving the 18 questions. And out of these, any type of question may that is formed in the exam. Question: a DNA was analyzed, means study of DNA was done. A DNA was analyzed and found to contain 2000 base pairs. Concentrate on the number. A DNA was analyzed and found to contain 2000 base pairs, out of which 21% were guanine. This value is very important to solve all the questions. Okay. Out of which 21%, what is that? Were guanine. Find out number of. Find out number. What is the question? A DNA was analyzed. When it was analyzed, it was containing how many base pairs? 2000 base pairs. Out of these 2000 base pairs, guanine was 21%. And what about the others? When guanine was 21%, find out the number of. What we are going to find out? Nitrogen bases. Remember, 2000 base pairs when present, how many bases will be there? That is into 2. Base pairs in the sense, one strand 2000, other strand 2000. That is total 4000 bases. 4000 bases here. Next, guanine given, how much it is? Already given 21%. Okay, 21%. Now first we have to calculate how much, that is how many pieces of guanine are present. That we have to calculate 21. Now we are supposed to calculate the percentage, then we have to divide by that is 100 again here into how many bases are there? 4000. Okay, already given is 21. So how much guanine we are going to calculate? That is these two 0 get cancelled, these two 0 get cancelled. So 21 into 4, what will it will be? That is 20 into 4. When you calculate like that is 80 and 1 into 4 that is 84. It is going to form that is 840 guanine only. That is number of guanine. How much it is? 840, like that. Now next question, cytosine. Of course, according to Charles' law, guanine equal to that is cytosine, because the amount of the molar concentration of purine equal to pyrimidine here. Here purine is guanine, pyrimidine cytosine. So when the percentage of guanine is 21, it will be pairing with cytosine, and again it will be in the equal proportion. That is one, and again it will be 21%. Nothing but what? 840 bases of cytosine, 840 bases of guanine. Okay. Now total adenine guanine, that is guanine cytosine, that is 21, 42%. 42% it forms now of total DNA. So how much it becomes? That is, I will write here 840. This 840 plus 840 will give 1680. What is 1680? That is total of guanine and cytosine. Now coming to percentage of adenine. What is the question? When the guanine is 21%, find out number of, like. So number of adenine will be, how can we calculate? Total number of bases. How many they are? 4000. Minus what? What we want to calculate now? But that is only number of adenine. So 4000 minus guanine and cytosine. When you subtract from this one, this, okay, it will give how much? That is, how it will form? That is 23 by 120, like that. So it will give 2320. Okay, like that. Out of that is 4000. When we subtract 1860, it will be 2320 bases. But they are what? Adenine plus thymine they are. So what we want to calculate? Only adenine. It means we have to make its half. How much it will be? How it is going to form? That is 1, and here again 1, that is here comes, that is 12, 6 and 0. That is 1160 are nothing but what? Adenine. 1160 adenine only. A for that is adenine. Now what will be thymine? Of course, we made here already half divided by 2. It is nothing but 1160. Okay, 1160 adenine pairing with what? 1160 of thymine. And when you make it plus, again it will form adenine thymine concentration. That is again interesting. Now coming to uracil, what you tell here? Uracil is present in DNA or not? Since it is a DNA molecule, there is no uracil. Uracil only found in RNA. It is a pyrimidine base and it is found in, that is RNA only, not in DNA. So no uracil, that is nil. Okay. Now coming to sugar, very interesting again. Sugar. Okay. Total bases 4000 bases on one strand, 2000, another strand 2000. Okay. Now what is here? On one strand 2000 and other strand 2000, it means again it will be sugar molecule will be 400 sugar molecules, ribose sugar. Next, phosphate. Again phosphate will be 4000. Remember, they are not asking phosphodiester bond. The question is again next here. Okay, they ask for only phosphate. What is nucleotide? Combination of sugar, phosphate and nitrogen base. Okay, so one sugar, one phosphate compulsory. Like that, 4000 sugar molecules for 4000 bases means that is phosphate will be again 4000. Now coming to nucleoside. Nucleoside means here we have to subtract the phosphate from the nucleotide. What is nucleotide? Phosphate, sugar, nitrogen base. So when phosphate is not considered, it is called nucleoside, means sugar plus bases. It will be again 4000. Right. Okay. Phosphate is not considered here in the nucleoside. Again coming to nucleotide. Of course, how many nucleotides? Not pairs. Single nucleotide. On one strand 2000 and on other strand 2000. And we are telling a nitrogen base pair like that. Okay. So here it will be again 4000. Are you getting clearly? That is nucleotide means one strand. What is DNA? It is a strand of polynucleotide. On one strand, how many nucleotides are there? That is 2000. And these nucleotides are pairing with the opposite strand. It will become again 2000 base pairs. On one strand, when it is told, it is only bases. When it pairs with that base pairs, like that. So 2000 on one strand, 2000 on other strand, that is 4000. Easy one. Next coming to glycosidic bond. N-glycosidic bond, you know where it forms? This one. Between carbon number 1 of sugar and nitrogen base. Nitrogen base may be adenine, guanine, whatever it may be, or cytosine, thymine. Like that. So how many sugars are there? That much of glycosidic bond will be there. Sugar, it is going to form bond with nitrogen base. Again 4000. Again 4000. Now what happens here coming to phosphodiester bond? Phosphodiester bond easily we solved in the previous question. Number of bases on one strand -1 and number of bases on other strand -1 again. So number of bases on one strand is 2000 -1, because I told you here the fifth end phosphate is free and it is not going to pair until the succeeding ribosome comes, like that. So 2000 -1 on one strand and another opposite strand, that is 2000 -1, that is it will give 1999, that is total on this strand, and again 1999. How much it will be? Totally 3998. What we did here, that is total number of base pairs, in bracket I will write -2. Why 2? 2 strands. Okay, if one strand is considered, that is this one. Single strand, then it is -1, and then comes to of course DNA double strand 4000 -2 in the sense 3999. What are those? phosphodiester bond. Phosphodiester bond. Now coming to next, hydrogen bonds. How can you calculate now hydrogen bonds? Now remember, between adenine and thymine, how many hydrogen bonds are there? 2. Between guanine and cytosine, how many hydrogen bonds are there? That is 3. It means bases formed by adenine and thymine, how many are there? Adenine, thymine. How many bases are there? Pairing I am asking. That is on one strand 1160 adenine, on other strand 1160 thymine. So in between these two, how many bands are there? That is 2 hydrogen bonds. It means 1160 into 2. What is 2 here? Number of hydrogen bonds. What is 1160? Base pairs formed by the combination of adenine and thymine. That is base pairs formed by combination or pairing of adenine and thymine. That is pairs we are calling 1160 into 2. And after that, I will write here 1160 into 2 plus coming to guanine cytosine concentration. Now what is guanine and cytosine pairing? Number of guanine, that is pairing with cytosine, that is number of base pairs formed by combination or pairing of guanine and cytosine. How much it is? 840. Remember, guanine 840, cytosine 840. It means pairing when you are going to consider, it will be 840 only. That is number of base pairs formed by the combination of guanine and cytosine. It will be 840 into what will be here writing? 3. Why? Guanine and cytosine contain how many, that is nitrogen bases? Guanine and cytosine, number of nitrogen bases, how many are there? Here I wrote 3. You know already it is when you are studying the structure of DNA. That is, hence we wrote here into 3. Now what will be the value here? It will be double, that is double again. Totally, how much is the value here? Okay, total 2320. Okay, plus, because into 2 we are calculating it. Plus here, what will give here? That is 83. Totally 2400 plus 40 into 3. I will write here separate. 8 into 3, that is 800. 2400 plus this 40 into 3, 120. What will be it one? That is 2520. Okay, so how many hydrogen bonds total? How much it is? 25 plus 2500 plus 2300, that is 4800. This 20 and this 20, that is 4800. 40 hydrogen bonds. Very easy it is. Okay, number of hydrogen bonds. This one. Now coming to number of helix. Okay, so it is slightly shifting the lower one. So just concentrate here. Number of helix. What is that? You know already how many base pairs are there? How many base pairs are there? 2000. That is number of base pairs. Each base pair contain how many bases? 10. Number of base pairs divided by 10. When you calculate like this, number of base pairs 2000 divided by 10 in the sense, it will give 200 helix. 200 helix, number of helix. Remember, one turn of DNA. Okay, which is completing at a distance of 34 angstrom, like that. Okay, so number of base pairs divided by 10. Why 10 we are considering? Because each base pair containing 10 bases, and hence 2000 base pairs divided by 10, that is 200 what? Helix. 200 helix. Now length of helix means complete DNA. Length of helix. Now first calculate here. Okay, I will write here. This is for this one. Okay, we will write here. 14th question this one. We will write. That is 15th here. That is length of helix. Length of helix. Now how can we calculate this one? Okay, total number of helix, how many are there? First write down how many base pairs are there. 2000 base pairs. Distance between each base pair into 3.4 angstrom. That is nothing but in nanometer 0.34 nanometer, like that. So 2000 base pairs. Each base pair that means how many distance gap is successive gap, that is 3.4 angstrom. So first make it simple. That is how many helix are there. If you know the number of helix, you can calculate the length of the helix. Helix nothing but DNA molecule. Okay. So number of helix 200 here into length of each helix now into 10 again, that is 34 angstrom it will be, coming to 6800 angstrom. 6800 angstrom is the length of this helix which contains 2000 base pairs. Very simple here. 2000 base pairs, distance between each base pair 3.4 angstrom. Okay, length of helix, number of helix, how many are there? 200. When you multiply it by this 34 angstrom here is distance or length of one helix. Okay, number of helix 200. That is, it will be 6800 angstrom. That is the length of this helix which is containing 2000 base pairs. Or when you convert it into, that is nanometer, it will be 680 nanometer. That is 10 times less. 680 nanometer. Coming to next question. For example, nucleosome. Number of nucleosome. Now how can we calculate? Okay, how many base pairs are here? Total number of base pair. Total number of base pair, that is 2000 base pairs. Okay, totally I will directly write here, that is 2000, and each nucleosome contains how many? That is divided by 200. Single nucleosome contains how many base pairs? I told you 200. When it is asked the bases, it will be 400. When it is asked the base pairs, single nucleosome contains 200. When that is number of bases divided by, number of bases 2000 divided by, that is this. What is this 200 came from? That is each nucleosome. One nucleosome contains 200. It will give 10. Number of nucleosome in this helix is 10 nucleosomes. Now coming to 17th question, base ratio. Now what is base ratio? According to Chadha, that is base ratio is species specific. It means in eukaryotes it is more than 1, in prokaryotes it is less than 1. Again in eukaryotes humans have different value, but that is more than 1. And again, for example, elephant have different value, but it will be again different from humans value, but more than 1 in eukaryotes and less than 1 in prokaryotes. So how can we calculate the base ratio? You know already this formula, A plus, that is G divided by, that is T plus, sorry, A plus T divided by G plus C is, that is always equal, that is constant 1. So what is here our value? A plus T, how much it is? This one, A plus T, that is 2320 divided by what? Guanine plus cytosine. What is guanine plus cytosine here? Guanine 840, cytosine 840. It will be 1680. Now simple one here. When you divide it, of course simple. Again, it is not required to go in detail maths here. So you can write directly. When the numerator is greater than denominator, it will be of course more than 1. It will be of course more than 1. So next question is here, 18th question. This DNA belongs to prokaryotes or eukaryotes. You can tell easily, when the base ratio is more than 1, this organism we are talking about is eukaryotic organism. Simple. Base ratio, what is that? Nothing but amount of adenine, thymine and amount of that is guanine, cytosine. Okay. And I told you in eukaryotes base ratio is more than 1. More than 1 because in eukaryotes content or amount of adenine, thymine is more than amount of guanine, cytosine. Now here amount of adenine, thymine is more than guanine, cytosine, and when the that is numerator is greater than denominator, it will give that definitely value will be again in point, 1 point like that. So it will be more than 1. So and hence when the base ratio is more than 1, it belongs to what? Of course eukaryotes. When it is more than less, it will be prokaryote. So like that, here we solved from a single question, we solved 18 questions here. Okay, correct, that is 18 questions. So they may ask any 1 or 2 questions from these. So don't get confused, everything is here, so get clear. And you can ask any doubt by your app, that is college app, whatever that is launched one by the institute, you can ask in that. Okay, that is good. After completing this, we move to our next again very interesting topic, that is search for genetic material.